requested from users, it was here in Sweden and in some other countries, where you needed to know the maximum sag of the power line. How much can it hang down according to special regulations that are within the power line business. And then you need to know the straight line, that's the red line on the presentation. And how this was done was that the workers needed to climb up the pole, and they used optical instruments. And then, I mean, this work is quite time consuming, you need special equipment, and it's also dangerous at some point, since you also have high voltage and you risk to fall down and things like that. So to get this value was requested from us, and if it was possible to do it in the unit. And then we developed the delta height function. And how does that work? So practically how you do it, you step aside from the line, but you need to see your left pole, and you need to see the right pole, and you need to see the line. So you position yourself where the line has the maximum sag, where it's hanging down the most. And then you straight forward to that position. Then first, you take your first measurement on the left side, where the line is attached. You send that to the memory. Then you take your next measurement to the right side, where the line is attached, and you send it to the memory. Then you aim at the line, and you press send again, and the delta height will be presented, and as you can see on the screen. So the unit calculates that. And what is good also now, that you could, if you press send once again and you have the GPS active, then it will store your location and all the measurements as well. Next function in the Geo is the line clear. And this function is quite visible on this presentation, but you want to avoid that the power is cut off. It costs a lot of money, it's time consuming, and many times it's during storms or things like that, so it's hard to get out and fix the problems. And if you can avoid that, you save a lot of money. So the trees that are near, you want to know if they are a risk to fall over the line or not. And this was originally done by our customers using a pen and paper. And this is, it's not so hard to do, it's not so heavy calculations, as long as the tree is standing on the same height or base, if it's not in a slope. But you know, it's almost never like that in forested areas. You have a hill, a tree up a hill, or you have it down in a valley, and the calculations are much harder. So we developed a function for the unit to calculate if the tree is a risk or not. And this is how it works. So you position yourself facing the tree that you want to control, straight to that tree. You need to see the line, and you need to see the tree from your position. You should not stand straight under the line, you should back away a bit more, so you have the line in front of you and the tree in that direction. Then first of all, you measure on the line, and then you press send. Then what you want to measure the tree. So what the function that is used now is the 3-point function as default, so you don't choose any function. You measure the distance to the tree, and then you measure the angle, and you measure the angle to the top, and you press send once again. The instrument will calculate if the tree will fall on the line with how many decimeters or not, and it will say a negative value or a positive value, and it will say okay or not okay. And in this function, you can see that it's the laser and the tilt sensor that is used, not the compass. Then we have a brand new function developed that came out in the latest software application, and this is called the min dist, and it's available if you go to line clear. You have the option line clear or min dist. And the min dist function is not the same as the line clear function, because the line clear, you want to know if the tree is a risk to fall on the line. In this case, it's mostly on local nets in cities where the lines are, or the power lines are, it's not so wide, so it could be forest very near these lines. But then it's a risk. If some branches are too near, they need to be taken away, because you can't take all the trees away. And the risk here is not that it will fall on the line, it's that it could cause fire. In this function, we are not using the sensors that are used is the laser, it's the compass, and it's the tilt sensor. So this was requested from customers that, for example, in Norway, we have got questions from this, and also in Brazil. And now we see that it's very commonly a problem that is, and it's very interesting. And of course, it could be other scenarios where this function would work, not related to this, solve other problems. But this is what you do. You step out from the power line, because you should avoid being in the line, because the compass, as you know, will have a problem inside the line because of the high voltage, the electricity there. It's the same as you should not use your cell phone nearby. You should not use metallic objects. It could be your car keys or anything like that, because it could interfere with the compass. So here we step out from the line, and now we want to measure and know the nearest distance from the branch to the line. So I take my first measurement at the left side of the line, and this is the left side of the tree in relation to the line. My second measurement, I measure on the right side, and for each measurement I press send to store that value to the memory. So my second measurement is on the right side on the line in relation in the tree location to the line. And then my third measurement, I measure on the branch, and it will calculate that distance. And this is a security distance. And normally in the branches could be taken away. Here in Sweden, many places they use a helicopter, and they fly with a big saw and take the branches away in these cases. Okay. So this was a short presentation